So guys, let's parent this ankle and ball to the ball locator, parent it, and then parent this toe to toe wiggle, parenting. So what control we are going to get from this is, if we move the heel, then our heel is going to be removed, and if we move the inside, it's going to move inside, and if we're going to move outside, it's going to move outside only, and if we're going to move toe, it's going to give this rotation, this. Okay, so let's make a controller for those also. So let's rename this BOY_001 underscore L underscore LE leg IK 01 underscore CC for control curve. So go to modify, add attribute. Let's add a first attribute. I've created some reference up here, not to write a name. Ball raise. Okay, control B, ball raise, float, and add, and let's make another one. HUL heel raise, add. So next one will be heel pivot, HUL heel underscore PI POT pivot, see, add, and next one will be side toe raise, SID side, add, TOE toe underscore RAS toe raise, RAIFC toe raise, and TOE toe underscore PI POT pivot, and the final will be TOE toe underscore WIGGLE. Okay, add. We have finished adding attribute. So what we need to do is create another group, control G. What this will do is heel locator, control C, control V, rename it GRP, and rename it boy01 IK, I think underscore L underscore IK locator 01 underscore locator. So what we need to get, we forget to add prefix up here, underscore L. Okay, so let's make it a small L. Okay, what we can do is control this all and move it along. Okay, so what next we are going to do is select this one, and go to constant and hit parent constant, add. Okay, we need to add a maintain offset, add. So what the control we are going to get is E. Okay, and what we are going to get is the IK. Okay, so it's working properly. So let's create some SDK controllers. So go to set driven key, load this as a driver. Okay, load this as a driver and load locator. Let's first, what we do is, it's coming in the way, so let's hide those attributes we don't need to see. Lock and hide selected. So let's go to set driven key, load it as driver, heel locator, load it as driven, and what we need to do is, I think, x-axis. Okay, heel raise, first we need to give a ball raise. So let's start with the heel raise. We'll go to this one. I think it's on a 0. Okay, and select driven items, rotate X, and heel raise key. We'll go to this one and put this to heel raise 200, and go to select driven items, and let's see how much the X will go when he will be raised. I think almost 75, not I think minus 75. Okay, that's okay for us. So okay, we have done with the heel raise. So now what we need to do is select driven. Let's zero it out. And what happened now is if you raise the key, it's going to raise. Okay, so next work on heel pivot, and I think heel pivot is 0. Select driven items. I think heel pivot will be rotate Y. Okay, so let's key selected. Okay, we have, let's select the Y on a sticky key selected, and select driven items. Okay, go to heel pivot, put it to 100, select driven items, and what we need to do is let's pivot it outside on 100, put it 100 up here too, key selected, and go to select, let's put the value of minus 100, and then select driven items, put the value of minus 100. Okay, now we're getting a heel pivot, and let's work on a ball raise. So select ball raise and select, I think, ball located. Select this one. I'll put it value to 0. Select ball located. It's going to, okay, the perfect way. Rotate as a driven. Select ball raise, and then select, I think X is going to the rotate axis. Okay, so key selected, and select, go to its ball raise, put the value of 100, and then select driven items, and I think X, put the value of 150. Right now it's going to be okay, let's not put that way, that much higher. Let's 74. I think 100 will be perfect. Now it's going to flip, I think 120. Yeah. Okay, but when you want to make a pole vector constant, it's not going to flip. So key selected. Okay, so we have done up with a ball raise. Okay, so let's see, ball raise working properly. Okay, so what we need to do is work on a side. So select inside, load driven. Inside means let's, okay, minus 74. So side, it's on G. Okay, select G, key selected, select this one. Let's put minus 50 sign, select driven items, and let's put it up here. I think 75 would be the perfect. Key selected. I think let's go and zero it out. Okay, now for the outside, load driven, let's G, key selected, and let's put it to 50, and select driven items, and this time put 75. Okay, outside minus 75, and key selected. Okay, and let's work for a toe. Select driven, select this and go raise. Okay, so select toe raise, and for toe locator, toe raise will going to be like this. Okay, so it's moving on x-axis, so select rotate x and key selected, and select this and put the value of toe raise 100 and select the driven items, put the value, I think 120 will be perfect. Okay, once you put a Paul vector constant, the flip problem will be solved. Key selected. Okay, so what you're going to do is, let's see the connection. Toe raise. Okay, it's going to raise a problem. For the toe pivot, we need to go to Y and key selected, and for toe pivot, let's put it to 100 and select driven items. I think 100. Okay, what we need to do is, let's put it just on to 50, and then select driven items. Let's put it to -75. Let's little bit exaggerated it. Okay, let's not, so let's put the value of -50. Okay, key selected, and let's go to -15. That's what we were. And select driven items. Let's put the value of 50 and key selected. Okay, so select this one. Toe pivot is working. The final is toe wiggle, and let's select toe wiggle and load driven. So what we need to do is, for this, let's try a different way. Let's try a connection editor. So go to select this one, go to Windows, General Editor, Connection Editor, load it as a driver, and select toe wiggle. And for us, I think we need to rotate, connect rotate X. Okay, so select it, toe wiggle, and for the toe wiggle, connect this to rotate X and close. So what happened is, it's connected and it move up and down, so you are getting the result of toe wiggle. So now we have created a IK leg setup. So when you move this one up, okay, E, okay, so it's created. So you can do this one, and either you can go to and raise your bar. So next what we need to do is create a Paul vector constant. So in next lesson, I am going to create a Paul vector constant and finish this IK leg setup and parent it to its group.